Hello, I'm Lee. In this video, we're going to look into abstract class and interfaces. So let's take a look at this class hierarchy we get from previous week. So in this class hierarchy, we say circle and rectangle, the subclasses of this superclass shape. And that's is a relationship. Circle is a shape, rectangle is a shape. And also this has a relationship. The shape object has a position object to handle the position details for the shape. Okay, so now let's see, we got more stuff going on here. There's an interface called drawable. We will focus on that one in the next part of the video. But right now, let's see, shape class is marked as abstract class. So let's take a look at what does that one means. So the class shape now got an abstract keyword, and it says it's an abstract class and it implements two interfaces. One is comparable and one is drawable. We will focus on interfaces in the next part of the video, but right now let's focus on abstract. What does that one mean? What makes it abstract? We still have all those concrete methods here. So let's take a look. I put in one extra method, and this method is an abstract method. You see, the reason it's abstract is there's no implementation of this method in the shape class. It ends with a semicolon. That's saying I'm not going to implement it here. That's why it's abstract method. Because I have an abstract method in the class, my class has to be abstract. So whenever you have one or more abstract method, your class has to be abstract as well. So although I have plenty of concrete method here, but still, because I have one abstract method, my class has to be abstract. So what does it mean to be an abstract class? When you're an abstract class, that means nobody can instantiate you. That means you cannot say new shape. You cannot create an object out of shape because it's abstract, because it doesn't have implementation for one or more method. So that's why you cannot instantiate. Then you might be wondering, why do you have this class then? Like the whole point of create a class is you want to use objects out of that class. If you can never instantiate, then what's the point of having that class? Okay, let's see. The second indication about abstract class and abstract method. We didn't provide any implementation here, but there's a contract right now. That means all the subclasses of shape, if they want to be concrete, they have to implement getArea. So they have to provide the implementation. So if you want to be my child, you have to implement this abstract method, and if you don't want to be abstract again. So that's the second indication about the abstract class. So the first one is you cannot instantiate the abstract class. The second one is for all your children, they have to provide the implementation. So that comes to the point about why we use abstract class. When we use abstract class, we say, sure, you cannot instantiate, but abstract class is useful to structure your program. Like, for example, this class says, I want all my children to have getArea. How do I make sure that happens? I put it right here, make it abstract. That way I can make sure all my children have to provide implementation for getArea. Otherwise, the compiler won't allow them to do that. All right. So that's the two indication about being abstract. So let's take a look at the circle class. For the circle class, you see the circle class extends shape and it's not abstract. That means it has to implement getArea. But good thing is at this moment the circle knows how to implement area. And the similar thing for rectangle class, it knows how to implement it. You see, in shape class, it has to be abstract because you have no idea what kind of shape is that, and you don't have the information to calculate get area. So the only point of defining it here is to make sure all my children have it. So what's the point of that, and why do you care that much about all your children have it? So this comes to the third principle of OOP. It's called dynamic bounding or polymorphism. So let's take a look at the client class. What do we gain by using abstract class? So let's first see. One, you cannot do this anymore because it won't compile. Shape is an abstract class. And you can still do new circle, new rectangle because they're concrete. And we create a circle and a rectangle. And then we add the shapes to this list of shape. You see the type information is list of shape. That means a list of any shape. It could be rectangle, it could be circle. Okay, and then let's see. When I use a loop to loop around, I say s dot get area. S dot get area. Let's take a look at S, the type information. The type information for shape for S is shape. So remember, in shape, you do have a get area, but that's an abstract method. So at this moment, dynamic bounding kick in. Dynamic bounding means which get area get invoked totally depends on at runtime what kind of shape is this. So the runtime type information for S. For example, the first iteration, that's for S2. S2 is a circle. Then this S is a circle at runtime, so the get area in circle class get invoked. And the second iteration, S3, that's a rectangle, then rectangle's get area get invoked. You see this is called dynamic bounding because which method get invoked depends on the runtime type information. And dynamic bounding also got another name called polymorphism. Polymorphism means the same line of code means different method invocation. So this same line of code could be invoking get area in circle, could be get area in rectangle or in triangle. So that's called polymorphism. You see, this is what we gain by using abstract method and abstract class, because when we write this code, we have no idea what's in S, what's a runtime type for S, but we can confidently put in this code because this is an abstract method in the shape class. So we know any kind of shape will implement get area. So that's what we gain by polymorphism. Thank you.